Have you ever wondered what a software engineer does? It's not just about typing code. Software engineering is like solving a complex puzzle where the pieces are requirements, design, development, testing, and deployment. It's an intricate process that involves much more than merely writing code. At its core, software engineering is about problem solving. It's about identifying a need or a challenge, and then designing and implementing a software solution to address it. It's a process that requires analytical thinking, creativity, and a keen understanding of both technology and human behavior. Moreover, software engineering isn't a solitary endeavor. It's a collaborative effort, involving communication and coordination with team members, clients, and sometimes end users. It's about testing and iterating, making sure that the software not only works, but works well and is user-friendly. So now that we have a basic understanding of what software engineering entails, let's dive deeper. So, let's dive into the world of software engineering and break down this process. The first step in the software engineering process is requirements analysis. In this phase, we delve into the nitty-gritty of what the software is designed to accomplish. It isn't just about coding, it's also about understanding the problem we're trying to solve. Imagine we're building a house. The requirements analysis is like creating a detailed blueprint, where we decide on the number of rooms, their layout, and the materials needed. Similarly, in software engineering, we figure out what features the software should have, who will be using it, and in what context. It's like a detective's work, piecing together the puzzle of the user's needs. This phase is paramount because it sets the stage for the rest of the software development process. If we get this step wrong, the entire project could veer off course. A well-done requirements analysis ensures that the software developed is user-centric, fulfilling its intended purpose effectively and efficiently. Once we've understood what the software needs to do, we move on to the design phase. Designing the software is the next step. Like architects crafting the blueprint of a skyscraper, software engineers design a plan for their software. This isn't just about what the software will look like, but it's also about how it will work. It's about envisioning the user's journey from the moment they open the application to when they close it. A good design is like a well-drawn map. It guides the user effortlessly through the software, helping them accomplish their tasks with ease and efficiency. It's a critical phase where software engineers lay the groundwork for a smooth and intuitive user experience. Simultaneously, the design phase is also about performance and efficiency. Here, software engineers determine the best ways to structure their code. They make crucial decisions about data structures, algorithms, and system architecture. With a solid design in place, it's time to start coding. Now comes the part most people associate with software engineering: coding. This is the development phase where all that meticulous planning and design comes to life. Here, software engineers turn the blueprint into a tangible product using programming languages like Python, Java, or C++. This phase isn't just about translating the design into code, it's also about problem solving. Sometimes the design doesn't translate perfectly into code, or unexpected obstacles crop up. That's where a software engineer's problem-solving skills come into play. They need to figure out how to overcome these hitches while still staying true to the original design and requirements. The development phase is also where the engineer's understanding of the programming language becomes crucial. Different languages have different strengths and weaknesses, and knowing how to leverage those can make the code more efficient and robust. Once we've written our code, we need to make sure it works as expected. The next phase in our process is testing. This stage is where the rubber meets the road, so to speak. It's where we put our software through the ringer to ensure it functions as intended. We simulate real-world conditions and push the software to its limits to see how it performs. Now you might ask, why is testing so important? Well, imagine launching a software that hasn't been thoroughly tested. It's like driving a car without checking if the brakes work. Not a pleasant scenario, right? Testing allows us to identify any bugs or errors in the software. It's our opportunity to spot any problems that might disrupt the user experience. We then fix these issues, retest, and repeat the process until the software is as close to perfect as possible. This iterative process of testing and fixing is crucial in creating a software that not only works correctly, but also meets the needs of the users. After we've tested and fixed any issues, we're ready for the final phase. The last phase of the software engineering process is deployment. This is the point where all the hard work of the previous phases comes to fruition, and the software is finally made available to the users. But don't mistake this phase for a simple handoff. It's far from it. Deployment can involve an array of tasks such as installation, configuration, and sometimes even user training. The software needs to be installed on the user's system or uploaded to a server for access. Configuration is key to ensure the software works perfectly with the user's system and meets their specific needs. And sometimes, especially when the software is complex, user training is necessary. This could involve creating user manuals or conducting training sessions to ensure the users are comfortable and proficient in using the software. Every stage is crucial, and deployment is no different. It's the final piece of the puzzle that brings the whole project together. And that, in a nutshell, is what a software engineer does. So, we've taken a journey through the software engineering process. We started with requirements analysis, where we identified what our software needs to achieve. This is a crucial step that lays the groundwork for everything that follows. Next, we dove into the design phase, where we laid out how we're going to meet those requirements. We discussed the development phase, where the actual coding happens, bringing our vision to life. Then we moved on to testing, where we meticulously checked our software for any bugs or issues that could affect its performance or functionality. Finally, we reached the deployment phase, where we launched our software into the world for users to benefit from. Throughout this process, we've emphasized the importance of each step, showing that software engineering isn't just about coding, it's about creating solutions that meet user needs and work as expected. It's a fascinating field that combines creativity, problem-solving, and technical skills. Thanks for joining us on this journey through the world of software engineering.